Okay, it's 8:30, so we'll go ahead and get started. Thanks for joining everyone this morning. My name is Jason Vandiver, and I'm Energy Code Program Manager for Spear. We'll be looking at some HVAC installation, best practices, just a general overview of HVAC installation, certainly highlighting a lot of the things that I saw wrong back when I was a code official. Uh, this will be an abbreviated 1 hour presentation. I've been doing this. A longer version of this is 2 hours, and it's live. Do have some upcoming in-person dates for this presentation: April 18th and 19th in Austin, April 23rd and 24th in Houston, April 26th in Uvalde, and then headed out to West Texas in June, June 4th in Lubbock, and then June 11th in El Paso. And then also of note, we do have a couple of upcoming webinars. We have Alex Meany with the senior trainer at RightSoft. He'll be back on April 29th with There's No Such Thing as a Ton, highlighting the importance of manual S. That's on a Friday. He's presents kind of my style. He's a very laid back, informal type of presenter, but he really knows what he's talking about. He's a senior trainer with RightSoft and has been doing it for a really long time and really knows his stuff. That'll be Friday, April 29th. And then our Speakers Bureau webinar series will come back in 2 Wednesdays on May 1st with continuous installation for code compliant high performance walls. So with that, let's go ahead and get started. My slides will work. So SECA, the State Energy Conservation Office, is sponsoring these live trainings across the state and some accompanying HVAC related webinars, which are also being greatly supported by TACA. So SPEAR, y'all know who SPEAR is, Regional Energy Efficiency Organization covering Texas and Oklahoma. Any way I can help you or your customers out, the price is right, it's free. Whether it's on-site training of insulation installers or a lunch and learn with builders or a presentation, maybe you're a code official in one of the last outstanding jurisdictions that is still on the 09 and you're moving to the 15 soon. I can come give you a presentation about changes from the 09 to the 15. And then those of you that use third-party inspectors, the offer still stands. Happy to come out and do some QA/QC work of your third-party providers. Just let me know. My email address will be here at the end. And then also for your ICC CEUs, you'll get a course evaluation. Simply fill out the course evaluation and Mariel will send you your ICC CEUs. SPEAR largely supported by DOE, but we also have about 50 member companies that help support us. Okay, so what are we going to talk about this morning? Breakfast is only in the live in-person trainings. Hopefully you've already had breakfast, but I can't provide that over the internet. So we'll look a little bit about a lot of what I culled out of this. It really just kind of left some flexed up consideration and some best practices. That's the majority of it this morning. So let's get started. For those of you that don't speak Spanish, this is, a really important part for the HVAC installers to know and code officials to know. If you're really either installing a quality HVAC job or inspecting and enforcing a quality install, I mean, $10, $20, $30, $40 a month easily on a quality install versus non and, you know, little old couple on a fixed income or single mom trying to buy groceries for her kid. It's important. So don't underestimate the importance of the job you do. And why is SECO interested in funding some of this? If we look at, these are summer weather impacts by load. So this is on ERCOT, for all intents and purposes, the electrical grid for the state of Texas. You see that on a day in Dallas when the temperature is 62, just a nice, easy day where there's not a whole lot of load for cooling. You look at the various loads versus large commercial, small commercial versus residential, versus on a day when it's 106, where presumably the HVAC load for residential is greatly increased. Well, the HVAC load for these is greatly increased as well, but look at the piece of the pie that residential takes up. It multiplies by a factor of 5, whereas, you know, small commercial goes up double and large commercial barely goes up. So if we can get more efficient equipment installed, and more importantly, HVAC equipment sized right, installed correctly, good duct layout, you know, reducing static pressure and increasing airflow, and all those important things that we'll look at this morning. We're looking to greatly reduce these peak load residential loads here. So we did, all of y'all have heard about the Texas field study. If you've joined us before, we've done down in the Houston area. We looked at a dozen or so energy efficiency measures, and duct leakage, HVAC efficiency, and square foot per ton were some of the things we looked at. Needless to say, the airflow in this duct, not the best, right? I mean, these flex duct come in 25-foot sections, and if you're 10 foot from your plenum to your register, well, you need to cut 15 foot off that 25 foot. One of the most important thing you can do with flex duct, other than having, I guess, a manual D, stretching it tight, the full length of flex duct. And we'll look at some of the manufacturer's installation instructions and the Flex Duct and Air Diffusion Council guidelines on this. So as far as HVAC goes, we're doing real good in Texas. These are some of the other states that were in the field study: Pennsylvania, North Carolina, Maryland, Kentucky, and Alabama. Duct leakage, we're also doing really well. I'm not so sure what in the world's going on in Pennsylvania. You can tell Maryland's been testing for longer at a tighter requirement. Some of these observations in Texas were based off when the 09 was still the state code, which allowed up to 12. Well, now, on the 15, you have to get to 4 CFM. So the next time when we do when we look at these numbers again, we expect that to drop quite a bit in Texas. Now this one's kind of interesting, and this goes a long way into showing part of the problem. Oh, and just one more housekeeping note. If you do have any questions, just on the Q&A panel down, just click on there and type your questions in, and we'll handle those at the end. But in Georgia, which fairly similar heating load or cooling load as we have in Texas, it's hot and humid in Georgia as well, but they've been requiring manual J and scrutinizing manual J for a few years now. Well, they're getting almost 900 square foot per ton in Georgia, whereas in Texas, we're under 600 square foot per ton. And this is a better indication of what, after talking to handfuls of HVAC contractors and code officials and seeing things in the field. So this is square foot per ton over here on the left. We had 70 observations. Evidently, this HVAC contractor sized the system for the 4th of July party. So this system's going to work really well when there's 50 people in the house on the 4th of July. The other 364 days a year, it will be grossly oversized. Of these 70 contractors, I would assume to guess that these 4 up here at around 900 square foot per ton actually are doing the ACA manual protocols accurately, the JS, and T. And then these other 66 out of 70 are using some sort of rule of thumb. Well, this guy's using 4th of July party. But as a code official, and I'll show you some ACA guidance here at the end, and some paperwork you can request at permit that will go a long way into helping reduce this. All of these grossly oversized systems, you know, these up here around 7 to 750, I would guess aren't grossly oversized, but anything else is, and you're going to have moisture problems in the house. There's a short cycling of equipment, energy penalties. There's a lot of really bad things that come along with oversizing, and we'll talk about that a little bit more. This isn't new to the energy code. This has been required in the mechanical chapter of the IRC and in the IMC for 30 plus years, as far as, you know, calculating the loads per ACA Manual S, selecting equipment per ACA Manual, calculating the loads per ACA Manual J, selecting the equipment per Manual S, and then Manual D would be the duct layout, Manual T's the terminations. You know, depending on what termination, it's going to change your static pressure. And all of that plays together, and using those manuals is the only way to do it correctly. We did look about a month ago or so. ACA has a new manual out called the LLH, the Low Load Home Manual, which goes with these other four. You know, especially in climate zone 3, where we're getting, you know, a 2x4 wall with the R5 continuous and under 3 air changes an hour. You know, we're getting a really tight quality building thermal envelope. We're going to have a lot of low load situations, and that low load home manual will be an important part of the process for, should be all HVAC contractors, but unfortunately for right now, it looks like it's just the really quality guys that are doing that. So again, this is required. It's, you know, we already mentioned the longer cycles dehumidify better. A smaller unit uses less power. There's lower upfront costs. You know, putting in a 3-ton is cheaper than putting in a 5-ton. You know, in August and in Texas, your HVAC should be running about 20 hours a day on a hot day. And then Energy Star and utility incentives, oftentimes there will be some incentives for right-sized systems. And why do we want to get that relative humidity in this 50% or so range? Well, you know, too much humidity, we've got mold, allergies, other issues. There can be some issues with too little humidity as well. And TACA, I put this slide in there. TACA sent me some slides. I've incorporated a few of those. Just so you know that here, you know, when TDLR gets a comfort complaint, whether it's on a new install or total replacement of a system, the first thing they're going to ask for is, where's your load calculation? Like for like is not a good answer if TDLR comes calling. So just be aware, if we have, for all of our HVAC contractors on the phone, and for you code officials that are wanting to start enforcing JS and D, you know, start requiring it at permit, start doing the things that the code says have to be done. You know, one of the good reasons you can tell your contractors is, hey, look, you know, TDLR is really cracking down on rules of thumb. They are you know, the very first thing when they get a comfort complaint, they're going to ask for a load calculation. So that'll help you hopefully win them over and understand the reason for requiring that. This was interesting. I got this off of Energy Vanguard, and basically, long story short, the Allison Bales, the author, I think it was a guest house that he was adding on, and calculated the load at 1.5 tons, and it was like a 1,800 square foot guest house or something. He just didn't trust it, so he went ahead and upped it to a 2-ton. even though the calculations were showing 1.5 could probably do it. When you look at the runtime here with the air conditioner on is the blue. And this is on a 90-something degree day in Atlanta, if I remember correctly, I believe. And typically, an air conditioner is not removing moisture unless it runs at least 15 to 18, sometimes 20 minutes, an hour. Well, you look at the number of hours a day that this only slightly oversized unit is removing moisture. We're looking at maybe 1, 2, 3, 4 hours in the day where it's removing moisture. The rest of the time, it's coming on, cooling the house down, and shutting off before that moisture starts to accumulate on the coil, drip out the condensate line, and get out of the house. So even just a half-ton oversize can really create some moisture problems. For those HVAC contractors out there or code officials that are giving some guidance, this would be a really interesting thing, especially, if they're working with a production builder or a builder that's, building that same house and they're putting in the same system. Put a data logger on that system. And that data logger will let you know the run times of that system, and it'll give you a better, you can confirm with your calculations whether or not, hey, we got that size right. It's running on a really hot day. It's running 45 minutes an hour. A data logger can really go a long way into showing you whether or not you did that right. Yeah, and this was, you say temperature here, so it was in the low 90s that day. So all of the manual J is based on the ASHRAE design conditions, and it's based on 1%. So yes, in Dallas, it gets hotter than 98 degrees, but only 1% of the time. And that whole, well, there's a 25-degree temperature swing. If it's 105 degrees outside, my customer's not going to be comfortable at 80 degrees in the house. Well, it doesn't, heat flow, thermal flow doesn't work that way. That's not a black and white, oh, it's going to be 25 degrees hotter or 23 degrees cooler in the house. It doesn't work that way. You've got the delta T through the building thermal envelope's going to slow that heat transfer. There's really, especially on a day, if it's going to be 108 degrees that day, and if you're comfortable at 76 in the house, before you leave the house in the morning, turn it down to 74 or 75 and pre-cool the house, and you're not going to get over 76, 77. Again, 1% of the time, don't fudge these numbers. There's oversizing built in. It's all accounted for in the calculations, so you're really doing yourself and your customers a disservice fudging these numbers. So let's look a little bit about just some general rules of thumb on installation. Obviously, we want, ideally, it's manual D, and we know exactly how long all these duct runs are and what the bends are and what the terminations are and everything else. If we are just using rules of thumb still and we're just insisting on not doing it by the book, well, then just some good general guideline is a centrally located air handler location to minimize the length of the duct runs, right? Properly sized, not just that one big central return. A lot of times it's good if you can get a return in each of the bedrooms, one in the hall. But you're going to get much better airflow with less runs and less likely comfort issues with a more centrally located air handler. Like, I'm not sure where they put this one. I love this picture, especially I think it goes a long way into showing that's probably not very centrally located, right? A little bit more about manual D. Well, it breaks down every little part, every little component of the duct system is calculated into manual D. Whether or not you've got diffusers, dampers, collar size, type, what, on your inlet, you want the width, and we'll look a lot at some Air Diffusion Council. Actually, some of these guidelines are from DOE, and I need to get on the Air Diffusion Council guidelines. I've been told after I've given this live training that they've updated some of this, so I'll make those changes before the next live training. But you really want a straight approach off all the exits. You want the exits on the sides only. This exit here showing off the end, you do not want that under any circumstance, right? Because if your inlet is here, all of that air is just going to go. You're going to be getting 600 CFM out of this duct and 15 CFM out of these four, you know. So you don't ever want to take off the end. You always want to take off the sides. You want so if this is a 12-inch inlet, you want the width here to be at least 24. You want this at least 12, preferably 18. Lots of guidelines in ACA Manual D guidance for junction boxes, and it all comes into play. It's all calculated into the design. There's various junction box configurations. The most important kind of rule of thumb with them is if you are doing a junction box, you want your longest runs on the back of the junction box, right? Because the air is going to come in and it's going to be moving faster towards the back of the box. Any short runs, maybe you've got a little 6-foot run to utility room here, you want those at the front of the junction box. Again, on the correct junction box sizing, the junction box width should be at least 2 times the inlet width. And at least 12 to 18 inches here, preferably 18. And I've been told the newer guidelines are showing 12 to 18 on the back end as well. And the number one thing you don't want to do is take off the butt end. Like this here. Absolutely not. All your air will just go straight through there and you won't have any coming out the sides. So we're looking at various junction box configurations. Obviously so that air is going to come through here, hit the back and be turbulent and not get out the ducts. Again, you want them towards the back of the box. And I've got to look at those new Air Diffusion Council guidelines on how they've changed that, if at all. It's no different on the triangle box than on the rectangular box. You want the longest runs toward the back end of the box. So as a code official, you're up in the attic looking at this, and you've got big long runs off the front and little short ones off the back. Maybe we need to swap these two, or at the very minimum, have a conversation. Take that as a opportunity to do some education of the HVAC installer. Hey, obviously you don't have a manual D here. If we're not enforcing the manual D, then let's at least make sure we've got the longest runs off the back end of the box. Off the plenums, the flex duct manufacturer's guidelines require that it to be supported straight off the plenum. That way, as the air is filling the plenum, it at least can start its run down the duct straight. Oftentimes you don't see this. This is straight off the flex duct manufacturer's guidelines. You'll see this a lot of times, right? I've got a little 8-foot leftover section of flex duct. I only needed 4 foot for this. I don't feel like cutting 4 foot off. Not only is it not supported straight off the plenum, it's longer than it needs to be, right? Well, what all do we have wrong here? Well, clearly, off the plenum, we've got one on the butt end, right? That's all. This is going to get all the air. This room's going to be nice and cool in the summer, nice and warm in the winter. These 4 rooms here, not so much. This plenum should have been double the length, and all of these ducts should have come off the side. There's room here to have doubled the length of that plenum. These flex ducts coming off the side. Look at this one, almost an immediate 90 coming out of the plenum. Again, these are 12-inch ducts. It should be coming straight off the plenum, at least 12 inches. Got a little bit of a sag here, a little more sag than 2 inches. Remember the flex duct manufacturer's guidelines. We'll look at some of these. This is interesting. I've been doing a little just driving around construction sites here in San Antonio. This is Meritage Homes. They do all of their junction boxes feeding from the top and then all coming off the sides with all their supply ducts. I haven't reached out to them yet to see if they've factored all that into their manual D or why it is they're doing that. just kind of logically, it seems like it would work pretty well, but I haven't gotten to the bottom of the why and if it's truly manual D or what they're doing there. Any radius in a flex duct, if you've got a 12-inch diameter duct, well, that radius should be at least a 12-inch radius. You are not sharper bends. They're going to increase static pressure and reduce airflow. Like this one here, right? What's that going to do? That airflow coming in there, not so good. You need to support your flex duct if you do have a sharp bend before and after the sharp bend. Otherwise, the flex duct manufacturer is fine at every 4 feet. The flex duct manufacturer says these straps need to be at least 1.5 inches wide. It is allowable to set them across the ceiling joists. Ceiling joists are 1.5 inches wide, so that is allowable. It's interesting as you go from jurisdiction to jurisdiction how the different HVAC contractors work. In the city of Temple, when I was a code official there, 19 out of 20 HVAC contractors laid them all across the joists. In Granbury, when I was a code official there, every single one of them hung them from the rafters. The flex duct manufacturer doesn't specify one way or the other. It just has to be supported every 4 feet and no more than a 1/2 inch per foot sag. So if you've got a 4 foot, that cannot be any greater than 2 inches right here. And I've written many a red tag for that good old flex duct that does, the old U-shaped flex duct sagging all over the attic. Please make sure that they get this as tight and as straight as they can. Vertically, it has to be supported as well. You're running between the first floor and the second floor. You can't just drop it down in the chase. It needs to be supported every 6 feet vertically. You want to eliminate any kind of crimping or sharp pressure, over any kind of framing members like that. That's going to reduce the airflow. Ideally, you'd have a couple of straps here and a smoother bend. What's wrong with this picture? I'm not sure why this duct couldn't have gone up over this one. It looks like it would have been a little better. And just when you go on a house or a commercial job and you see something like this, make the HVAC contractor fix that. There is no reason to have this kind of install. I mean, I understand that in some of these spaces, room is tight and you can't get it the way you want it, but you can certainly get it a whole lot better than this. This is one of my favorite pictures. Now that's a heck of a junction box there. And you know what though? That's probably meets your R8 requirement. If you had a good mastic seal, what would a big old block of dry ice do in that if that's a supply? I was like, oh, heck, that might be the way to go. And as long as we're talking about cooler themes, I'd be curious for any HVAC contractors on the line to tell me what they think all is in this cooler. But I just came across that one, and it went so well with this one, I had to throw it in there. So why is it so important to fully extend the flex duct? It's super important. Look at just a 15% reduction in a fully extended duct. You're going to have 2 times the friction rate. And when you take a 25-foot section of flex duct out of the bag and it's a 19-foot run and you're 30% compressed, you're going to get 4 times the friction rate. What's inside the flex duct? Ridges, right? It's got ribs. Well, every single one of those, if it's not pulled tight, will create turbulence with that airflow, increase your friction rate, and cause you comfort problems. Just think about in your head. So think about this plenum. We've got a collar, a damper, a couple of 45s, 12-foot run, a 90-degree, and a termination. What would be I should have put a poll question on here. When I do this webinar again, I'll definitely put a poll on here. What's just any guesses on the equivalent duct length of this 12-foot section? Let's think about it for a second. Feel free to type it in the Q&A if you'd like. Well, the entrance fitting adds 35 feet. the total duct length is 14 feet. We've got two 45-degree bends. A 45-degree bend adds 10 foot. A 90-degree bend adds 20 foot. The exit fitting's 35 feet. So this 12 foot from plenum to room on the calculations is actually 124 foot of total equivalent length. So is it important to do a manual D? Is it important to know these numbers? Is it important to figure this stuff out? Absolutely. What do we see wrong with this one? Again, this is one of those Meritage homes where they feed from the top and they come out all four sides of the box. Well, why in the world would this have not just gone? It looks like it runs straight here. So this, as a code official, again, hey, let's pull this out and run it straight so we can get a little better airflow to this room, reduce the static pressure for all this. We talked about, again, the 45s adding 10 foot of equivalent length. We already mentioned that in the example. 90s adding 20 foot of equivalent length. So, you know, this 4 foot, 246, we're adding 240s or 220s. That's a 50 foot equivalent length, your pressure drop. So let's talk about splices and connections. Obviously, coming out of our collar, we want a bead of mastic about as thick as a nickel. You put the liner on, zip tie that down, not just pull it with your hand tight. Use the little clamp to tighten that zip tie over the mastic, get it super tight. If you're splicing two pieces of flex together, you need a metal sleeve, you know, mastic on both sides, zip tie on both sides, pull the jackets tight so they touch, so you got a good continuous insulation on the entire section run. And just going a little bit further about that. And again, you know, I've caught more than one HVAC contractor just pulling those bands hand tight. You need to be using the clamp and the crimpers to get those tight. Again, it's mastic, liner, clamp, jacket, clamp. Some code officials, I don't know if any of you code officials on there red tag for not having mastic on the jacket. You know, if certainly it doesn't hurt anything. You know, it really shouldn't help anything either. If you've got, I guess it would create maybe perhaps some condensation issues that might occur. But really, if you've got a good seal on your liner, you pull your jacket all the way tight to the plenum and put a good zip tie or band on the jacket. Flex duct or the mastic really shouldn't be necessary on the jacket. I know of few code officials that want to see it and require it. Technically, code and the manufacturers don't require it. And certainly the most important place is on the liner. Now, again, you do want to get that jacket pulled up really tight. Here's your damper lever. So again, on a splice, two bands, mastic on both liners, pull the jackets tight so that there's no missing insulation. A couple more clamps there. We talked about having, enough room is an issue. We already mentioned that. And there are going to be some, cases, especially on change outs or whatnot, where you just couldn't, on a total replacement, where you couldn't get the size plenum you needed. And so one thing you do want to avoid on that, though, is that butt-in takeoff. If at all, the absolute one thing you want to avoid is take off of a run on the butt end if you can. Like this one did not. I mean, this right here is going to be a problem. These aren't fully extended. So a couple of them aren't. One real important thing to do, right, is we need to seal the drywall termination all from above with flex duct. Sometimes the insulators do it with a second stage poly seal. I would wager to guess that the mastic gets a better airtight seal than a poly seal, but the code just requires it sealed to the drywall. You need to be able to adjust the airflow coming out of your plenums, right? So we've got a collar with a damper. It needs to be able to, you can't balance. How are you going to balance the system if you can't go in there and adjust your airflow? Austin is the only jurisdiction that I know of residentially requiring air balancing, but certainly, that's best practice. That's any of your really good HVAC contractors out there, I'm sure, do a test and balance of new installs. You can test the leakage of the duct either pre-drywall or at final. Needless to say, if you do it pre-drywall and pass the test, a couple of things to be aware of as a code official. If you get that piece of paper saying the ducts passed the leakage test, well, when you're doing your final inspection, pull off one of the diffusers or look at one of the boots from the attic side. Make sure they're sealing that to the drywall. And then number two, when you're up in the attic checking insulation levels and wiring and terminals and all the other things you're looking at when you're in the attic on a final, make sure that the security guys are notorious for stepping on a flex duct or knocking a duct off a boot. There can be some issues. I know some raiders that will swear testing pre-drywall is the only way to go, and some are equally vehement that testing at final is the only way to go. In my mind, testing at final is a better idea just because of those things we just mentioned with the security guy and the possibility of some issues that happen. Hey, maybe both would actually be the best. Again, with the 2015 code, we're looking at 4 CFM with the air handler unit in place, leakage. I don't know anybody that tests without it in place. A couple of months ago, we saw that in the 2018 code, there's a buried ducts provision. Just remember, if you are wanting the buried ducts credit in the energy code, that's 1.5 CFM leakage if you're wanting to qualify for buried ducts. So what are some structural considerations for running HVAC, whether it's suction or condensate or whatever lines you're running? Needless to say, any engineered lumber, don't cut into engineered lumber without the engineer's okay. On regular dimensional lumber, we have some guidance in the code that allows notches up to 1/6 of the depth. But remember, in the middle third of that span, no notches are allowed whatsoever. Again, on LVLs, glue lams, any engineered stuff whatsoever, do not. Now, obviously, this wasn't cut for HVAC, but you cannot cut engineered lumber whatsoever without the engineer's approval. Maybe your line set. I realize this is a plumbing pipe, but it works the same way for a line set. You need your 16 gauge metal strap, 8 10D nails on each side. Once you notch that top plate, you've got to have the strap there in protection, right? For condensate line, if you're running a 3/4 inch condensate line, there's no reason to bore a 2-inch hole in that wall. This is just straight out of the IRC, notching, boring requirements as far as you see this on condensate line quite a bit, issues with condensate. Thermostat location. I love this thermostat here. That's just on off. It's either running or it's not, right? Typically, you're going to place a thermostat near a main return. And just keep in mind that really ACA has some guidance where you look at the rooms where the cooling airflow versus the heating airflow is the closest. And you really want it, plus or minus 15% of that design airflow. Those are the rooms you want it in. Typically, some kind of rules of thumb is we put it near a return. We keep it out of direct sunlight. We keep it away from where a supply is going to blow on it. And we definitely don't want to put it in a room like the kitchen where the heating and cooling CFM differential is going to be the greatest. Again, so the next couple of slides, I was asked to include, this is some TDLR's new, there's a new mechanical code change in regard to the sediment trap on gas piping. So, and I've never really seen it installed the other way much, but now in the 2015 mechanical code change, this flex connector has to be downstream of the trap. Sometimes we'd see it like this, right? The sediment trap right there at the water heater. Now the sediment trap's going to need to be over here, and then your flex connector into the water heater. So that's a change in the 15 code. It's funny how all my mechanic buddies have a bunch of broken down cars in the yard, and my computer tech buddies all have 3 or 4 busted up computers that don't work. There's no doubt that a HVAC contractor lives here, right? Or at least a technician. And I'm pretty sure that outdoor pic, this is what his attic looks like. I looked at this for quite a while and still can't figure out exactly what all he's got going on in this picture. But let's look at, since we've got about 15 more minutes, we'll look at, I've been encouraging code officials to do this for a while. There's a ton more resources out there. ACA and TACA have some really good ones. There's a ton on ACA's website. ASHRAE is a really good one. Building America Solution Center is fantastic. Go to your manufacturers and your trade associations. We're always here for you. The State Energy Conservation Office is always here for you. And if you really want to get a nerd, man, get nerd out on some of this building science and some of this stuff. Energy Vanguard is a fantastic blog. And I've watched a ton of YouTube videos preparing just kind of a base knowledge for some of this. And again, if you want any of those trainings, QA, QC work, whatever it may be, this is my email address. Please don't hesitate to reach out to me. No questions too silly. Happy to answer, connect me with your engineers, your architects, your builders, whoever it may be. Anyway, so let's look at a couple of those resources real quick. So for code officials, if you'll Google ACA Residential Design Review Form, okay, this page right here will come up. And you've got the review form itself for ICC or UMC. If you're still on, Austin, not too many are on the UMC. But, and then there's a whole 20-page document, understanding and using the design review form for your plan reviewers. Fantastic document. And then actually an illustrated example where they pull items out of the JS&D and incorporate it into the documents. So what do these documents look like? Well, the residential system design review form is this right here. It's a 1-page document. That's the bottom. This is the top. This is all there is to it. If I ever fall off the wagon and become a building official again, this will absolutely be required for all new residential construction. We talked about all these comfort problems. We talked about the grid's reliability. We talked about all of these things that are crucial into getting a well-designed, properly working system that will dehumidify correctly, all the things you want it to do. Well, to do that, so this 1-page form that you could require at permit just has, about 40 blanks that they fill out. But also, hey, do we have our manual J attached? Did we use the J1 or the abridged edition form? Do we have our manufacturer's performance data? We can't fill this out correctly without it, so that needs to be on here. Manual D friction rate worksheet, that needs to be on here. And then a duct distribution system sketch needs to be attached. So to fill this out correctly, all of these blanks come from your manual J. So to fill these out correctly, you would need to have done your manual J. All of these blanks are coming from our manual S. So what's the latent, sensible, all of the really important things, CFM, blower data, all that, manual S. And then friction rate worksheet, manual D. We're looking at this little section here. and then, hey, sign it and say you did it correctly. Cool thing about plan reviewer or about this guide. So this is the same form, right? These things are attached. This is the same form, but then it breaks down each of these blanks and gives it a number. And then it has a corresponding sheet that, oh, hey, from your manual J form J1, the room dimensions and floor plan area, which goes in blank number 9, is found here. Blank number 1 and 2 is found here. And so it shows you where to find so those accompanying documents that they submit, this form will show you how to go in there and find all that. Because it can be pretty daunting, as a plan reviewer, as a code official, yeah, I'm going to start requiring them to submit a manual J. Well, if you've never seen one, it can be pretty challenging to read one of those. And so this kind of really breaks down a lot of that and shows you, this is on the performance data on the manual S section. Hey, what's the total capacity, sensible capacity? What kind of CFM, horsepower? We're looking at all that stuff, right? And so this is a little 6-page guide. The manual D part, the friction rate worksheet part. Hey, what's our static? And then, hey, this is really important too, right? We've got a CFM for each room. We've got a duct design. We've got it laid out so that we know what size duct, what the bends are. All of that's going to come into the static pressure and total effective length of our duct system. And so that kind of shows you to make sure that they filled it out correctly. So this little 6-page guide will show you how to translate the attachments to this form and make sure that they're transferred over correctly. And then this 20-page guide or 13-page guide, it goes into more detail as far as why. So where this is, what it says, and again, it'll go in and each blank will be numbered, and it'll give you a little more guidance into how to fill that out and what will be the proper inputs for that. So, and I'll send these hyperlinks along with the course evaluation and really encourage you code officials to start requiring this 1-page form at permit for residential. So with that, we have a couple of questions. We'll get to those and then we'll call it a day. It says, we run manual JS&D as part of our 2015 energy report work in the DFW area. Most of our square foot per ton are 750 to 800 square foot per ton. Is it possible that the higher numbers that we're showing, they were actually around 900 square foot per ton, but he's showing 1,000, are from outside the DFW areas? Yes. So the numbers we were showing in the in our field study were actually all from the Houston area, and Houston's going to have, yeah, it's really humid in Houston, but it doesn't get quite as hot. It's a 95 or 96 degree design temp, whereas the DFW area is typically 98. So that will have been part of it. And then again, so the key thing I think to take away from that question is, hey, this person asking this question is running the JS&D. He's doing this work for his builders. His HVAC contractor has bought into it. He's selling it, and he's getting 800-ish square foot per ton. So if you're not seeing 800-ish square foot per ton, certainly if you're seeing a 2,500 square foot house and you got an IC3 report and it's showing a 5-ton unit for that 2,500 square foot house, that air conditioning system's grossly oversized. And I can totally understand if you're not wanting to move, the headaches that accompany, if you know all your HVAC contractors are kind of using these two words don't really go in the same sentence, but best practice rules of thumb kind of criteria, well, at least get them to get up to that 700-ish square foot per ton at least. I mean, that 2,500 square foot house, there's no reason. I guarantee you do a JS&D, and it's it's probably a 3-ton, no more than a 3.5. So help guide them. You know, if they were putting a 5-ton in it back when 10 years ago, when windows weren't as good and when the house wasn't as tight, well, then they need to bump that up. I mean, granted, rules of thumb and HVAC sizing never belong in the same sentence, but help these guys, help the builders understand that windows are better, building envelopes are tighter. You know, all these things go into play, and we have to change our HVAC practices. And if nothing else, I mean, builders, HVAC contractors, and this is really part of the problem, HVAC contractors charge per ton, right? So just for math simplicity's sake, let's say a 3-ton is going to be 6,000. We'll say 2,000 a ton. Well, putting in a 3-ton is 6,000. Well, a 5-ton is 10,000. Well, that's that difference. You could hire a company that specializes in JS&D, pay that company $500, $600, $700 to do your JS&D. You'll have an accurate load, proper equipment selection, a good duct design, and then you put in a 3-ton versus a 5-ton, it'll actually be cheaper for the builder. It can be. You know, it literally can be cheaper for the builder to do it right. So builders that complain, you know, even if the HVAC contractor say he doesn't have the expertise or the desire to do this, well, you know, you can have a third-party company do it. Now, for the third-party company to, there can be some caveats there. They could, depending on if they're turning it over to the homeowner or the contractor, they're turning it over to the homeowner, well, then they need to be licensed in the state of Texas. If they're giving it to a contractor, well, then that contractor is going to assume the accuracy of that once it's given to the contractor. But if it's given to the builder, well, then the person doing the load cut, the JS&D, needs to be licensed in the state of Texas. Next question: can you address ventilation on Manual J? Yes, all the ventilation inputs are going to be in the Manual J. And I go into part of what was culled from the presentation this morning is some best practice and my ventilation rant in general, and just how, man, we are, and just in my opinion and most experts' opinion, we are not doing ventilation even close to correct, even if we're doing it code compliant. I mean, to do whole house mechanical ventilation and make it compliant with code, you can put a ASHRAE 62.2 compliant exhaust fan in the master bathroom, and if it exhausts the CFM per square foot number or per bedroom number that's required in code, and it's controlled, the light switch on the wall is a control. You tell your homeowner, hey, this is your whole house mechanical ventilation. Just leave this on 24/7. Well, that doesn't make any sense, right? And so what I would highly encourage for any of the builders on the webinar this morning, or any of the code officials that the builders come to for advice, is a whole house ventilation system that actually is smart. I mean, I know of one manufacturer that makes one for $350. It's fantastic, because the important thing to me, especially down there in the Houston area or where we have humidity problems, is if it's 90% relative humidity outside, I want my whole house ventilation system to know that, to shut off, and then to ventilate at a higher rate in the evening when the humidity calms down. And so really that humidity sensor needs to be in the airflow path. You know, a humidity sensor in the house doesn't do you any good as far as the outdoor air you're bringing in. You've already brought in way too much of that humid outdoor air before that humidity sensor in your house picks it up and shuts it off. You need an inline. It needs to be in the airflow path. So if it's too hot or too cold or too wet, your whole house mechanical ventilation shuts off, right? I mean, you don't want to be bringing in that outside air. But the Manual J does, your mechanical ventilation is incorporated in your Manual J. And, you know, a lot of times it'll, you know, you do your load and it comes out at 2.5 tons or 2 3/4 tons. And, oh, I forgot to do my ventilation. Well, obviously, if you're bringing in outdoor air, once you incorporate that manual ventilation part, it could increase your load 1/4 ton. It's certainly going to increase the load. Next question. Concerning manual J, is there a default setting for internal shading closed percentage? I've been using 50% closed for windows unless it's obscure glass or living area. There is a default. I don't know exactly what it is. On the first, when Alex Meany with RightSoft, he is a manual J guru as far as all the defaults. And what I know what he'll tell you don't use any defaults ever, period. Put in what the house is going to be. He's especially vehement when he talks about tight versus semi-tight versus loose being a default. He really hates those, and he's shown me just how those can change the load by half a ton. Typically, I mean, internal shading, well, you assume that, what do you assume? Do you assume that half the people are going to put in mini blinds? Well, if half the people put in mini blinds, then do you assume that half of them close them? I mean, anybody with any sense, especially if they're going to leave the house during the day and there's windows that the sun comes directly in on, you would close those blinds. Me personally, I work from home. I like the blinds open all day for the natural light. Now on my east-facing windows on a hot summer morning, I'll close those. And on my west-facing windows in the evenings, I'll close them. But that's a tricky one because that has to do with human behavior. And I would think a 50% would be a pretty good default percentage to use. But honestly, I don't know, and we'll ask Alex on the first. Last question, and then we'll call it a day. Humid climates. Dehumidifier increase from heat and latent heat on supply ventilation to return. Humid climates, to me, code is the crummiest house we can build, right? I will beg and plead and make my very best case. Again, if I ever fall off the building official wagon and I'm hired as a building official down around the Houston area or down around the Beaumont area, whole house supplemental dehumidification should be the worst house you could possibly build, in my opinion, in that area. There's different ways you can set up that dehumidifier, and it would depend, it's going to affect your latent loads depending. I mean, I would get with the manufacturer and go through the data and just take a real good look at what that's going to do as far as changing your load profile. Last one. Where does it mention, whether in the code or duct, manufacturer installation instruction, anything about preventing crushing duct insulation when not using duct saddles? Basically, installers are using that 1.5-inch nylon duct straps. I've seen plenty of ducts condensating where they are just strapped because the strap is crushing the duct insulation, and the humidity in the attic has caused the duct to sweat where the duct insulation is crushed. It doesn't say it anywhere in there. It just says supported by. Saddles are not required. Are they best practice? Absolutely. I fall off the code official wagon and am working in Beaumont or Houston, I would probably require them. The manufacturers don't require them. Now, where it does say where you could get them in code for that, it doesn't say saddles are required in the flex duct manufacturer's installation instructions. It doesn't say it in the IMC or the mechanical chapter of the residential code anywhere. But what it does say is if something along the lines, I remember I had an engineer I was making, so they had a fully foam encapsulated house, and they would run a hard metal, like a 20-foot plenum off the air handler, just sheet metal, and they would foam about the first 10 feet of that 20 feet and then leave the rest of the sheet metal exposed, and because it was in a conditioned attic, and then just run little flex run jumpers to the rooms. Well, it's August. I go up in the attic to do a CO, and the painter, the doors had been open and the air conditioner had been running for 2 days straight as painters and trades are getting in there doing punch out and whatnot. But air conditioner's been running nonstop. Well, where that sheet metal wasn't foamed, it was dripping on the drywall. And I call I leave them a red tag. Hey, insulate this sheet metal. And the engineer calls me all in a huff. Well, I need to talk to your chief building official. I'm like, well, you're talking to him. Well, that's not going to, that's once that house comes down to temperature, that's never going to drip again. And you know, first he insisted that it wasn't condensating. And I said, well, I was up in the attic and I saw it with my own eyes dripping on the drywall. And long story short, there is a section in the code where it talks about damage to building components. And clearly that condensation is causing damage to building components. If you'll use your little search function in the IRC or IMC and just search damage to building components, you'll find that code section that you could give them a red tag if they are having condensation problems. You know, I'm assuming in those really humid Houston, Beaumont areas, then that's where you could use that section of code and require the saddles. But long story short, so that engineer was arguing back and forth, and I was like, well, what happened, you know, when this house is foreclosed on and it's sitting there vacant in June and July and the new people are moving in August, it's going to be dripping on the drywall again. So again, just Google search damage to building components in your ICC if you have an electronic copy, or shoot me an email if you don't have an electronic copy and I'll find it and send you the code section. Last one. Thanks. Example, design nail salon, 14 tons, OA ventilation and drop to 10 tons, 1200 CFM ERV. Builders always wanting cheap, working hard on training and making them understand intent of code to save energy savings. Not sure exactly what all that means, but I know on nail salons, 85 CFM of ventilation at the nail station. I know I was when I was a code official in Granbury, seems like our nail salons changed owners about every 6 months. Anytime we had any owner change, we would do what we call a CO Rio, and the fire inspector and I would go in the building. We were just looking for life safety type stuff, you know, egress, lighting, make sure you weren't storing stuff all in front of your electric panel that you couldn't get to, you know, just life safety type stuff. Well, needless to say, any of those older nail salons would knock you down every time you walked in them. The chemical smell was unbelievable. And so I really started doing some digging in the IMC when we were having a new nail salon come in. And it doesn't specifically say it in the code, but it does say 85 CFM per station. But if you don't have that suction at the station itself, you're not going to be able to remove that smell. Clearly, the intent of the code is to remove the indoor air quality and the noxious odor problems. So that 85 CFM of continuous exhaust at each nail station is a code requirement, and nail salons are a big problem. And I highly recommend you look at that next time you're permitting a nail salon. So anyway, that's all we have today. I appreciate you joining us. You will, like I said, you'll be getting a course evaluation. If you'll fill that out, you can get your ICC CEUs. And I'll send the hyperlinks for these residential design review forms. And just shoot me an email if you're interested in any of the other trainings. I'll send you at least a list of the dates and cities of the trainings. Let me know if you want to attend any of those in-person trainings. And that's all we got today. Y'all have a great afternoon. Thank you.